Okay, hi everyone. My name is Theresia Rampisela, and I'm very pleased to present our work on recommender system evaluation, specifically on fairness. So, this work starts with the question, how do we know if a scale is broken? And when a scale is broken, can we trust its measurement? So specifically in this work, we look into scales of fairness, or the ones that we commonly know as evaluation measures of fairness. To give some context about fairness in recommender systems, so given the top K item recommendations across M users, we asked ourselves, are these recommendations fair? And then two more questions come up after that. The first one is, what is fair? And a common definition to this is similar individuals should receive similar treatments. And then another question is, who is it fair towards? So in terms of granularity, we can divide this into individual fairness or group fairness. And in terms of the stakeholder involved, we can divide this into user fairness or item fairness. And in our case, we choose to focus on individual item fairness. And why do we focus on this type of fairness? There are a few reasons. The first one is due to popularity bias. Some items can be recommended more often than the others, and promoting individual item fairness may be helpful for new item discovery. The second reason is by assessing distribution across all individuals in the population, we can get a broader view by measuring individual fairness. And the third reason is because of the sensitive attributes, for example, gender or age, that is often used in group fairness computation, and these are used to identify the protected groups. And these attributes, they are often unavailable due to legal or privacy reasons. And the evaluation of individual item fairness does not always require this information. So there are a few more terminologies and definitions related to this type of fairness. The first one is exposure. This is commonly defined as the item appearance in the top K recommendation and at which rank position. And the second term is relevance. So this concerns whether the user will find the item relevant or interact with it. So to summarize, given recommendations across all users, individual item fairness would mean either all items having equal exposure, regardless their relevance, or there's also the second definition, where all items should be allocated exposure that is proportional to its merit or its value, and this is often taken as with using relevance as the proxy. So to give a more intuitive example of individual item fairness in recommender system, here we want to recommend 2 items from a pool of 4 items to 2 users, and these are all the items in the dataset, supposedly. So in the first case, we recommend things like this, so that only 2 out of 4 unique items are exposed or recommended. And in the second case, all 4 items of the dataset are exposed in the top K. So according to the first definition, where all items should have equal exposure, then because there are more unique items exposed in case 2, then case 2 is fairer. But what about the second definition, exposure with respect to relevance? Well, we need additional information on the relevance. So in the first case, let's say all the exposed items are relevant. And then in the second case, maybe not all the items are relevant. So here, in the first case, the items get more exposure that is more proportionally to their relevance. So case 1 should be fairer. However, which case is fairer depends also on the evaluation measure. And then following the 2 broad individual item fairness definitions, there are 2 types of measures. The first one is fair measures, which measures fairness only based on exposure. And our previous work has investigated the theoretical and empirical limitations of these measures. Then there's also the second type of measures, which we denote by fair plus rel. And these are so-called joint fairness measures that consider exposure with respect to relevance, and it will be this talk, basically. Okay, back to the main question of the paper. Can the fairness and relevance, or let's say joint measures, be trusted? So to answer this question, we look into the agreement of the measures and the sensitivity of the measures. So the first two research questions concerns the agreement between the joint measures themselves and also between the joint measures and the single aspects measures, which is the fairness-only measures and the traditional relevance-only measures like NDCG, recall, precision, and so on. As for the sensitivity, we look the sensitivity of these measures across decreasing rank positions and also given increasingly fair and relevant recommendations. So to investigate all of this, here are the following experiment setup. We run it on 4 real-world datasets, but due to time constraint, we can only present the results from last FM dataset, but the same trends can be observed in all the rest of the datasets. And we use 4 recommenders, starting from the strong baseline item KNN to state-of-the-art method NCL. And we also use one fair re-ranker, which is based on COM-MNZ, and it is based on item coverage and predicted relevance. After that, we compute all these results with 20 evaluation measures, which consist of 6 relevance measures, 5 fairness-only measures, and 9 joint measures. And these 9 joint measures are all the ones that we can find. And these are the evaluation results of all the measures. 2 things that we notice. The first one is that there are some joint measures that have extremely small scores. So it makes it very difficult to distinguish across models per dataset because everything is like 0.000, and we have to print until the 5th or 6th decimal place to sort of tell the difference. And then the second thing is that there seems to be a scale mismatch between the single aspect and the joint measures. So for example, this NDCG score differ by around 0.16. Then the fairness measure differ by 0.14 approximately. So we can argue that these are non-negligible differences. However, some of these joint scores, they differ by less than 10 to the power minus 3. So we ask ourselves, is this difference negligible or not? And yes, there is some explanation why this happens. We look at this measure called IFD, and this is the equation of the measure. So we focus on this term, JUI, and this is essentially a function that combines the item relevance and the item exposure. So what happens is that this term is often 0 because there are not many relevant items for the user based on the test set. So when this term goes to 0, then JUI goes to 0, and then IFD, the measure, also is very close to 0. Then moving on to answer RQ1 and RQ2 on agreement between the measures. To do this, we compute Kendall-Stone correlation between the ranking of models from best to worst based on the different measures. So here are the correlations. The y-axis are the joint measures, and then the x-axis are all the types of measures, the 20 measures. And we found 3 groups of similar joint measures. The first one, IBO and IWO, they have inconsistent relationship with single aspect and joint measures across 4 datasets. Unfortunately, it cannot be seen here. And then the second group of measure, IAA, HT, and IIF, they do not seem to align with fairness because they have quite a strong negative correlation. And the other 3 measures, IFD, MME, and AIF, they tend to disagree with relevance. So why do we see this, and how do we interpret this? So I will answer the second question first. No joint measures seem to reliably account for both relevance and fairness then, because they are either inconsistent or they just align with fairness or exclusively with relevance. So why do we see the 3 groups of measures? And it's all due to the similar formulations of the measures. For IBO and IWO, both are fractions of items with an impact score greater or lower than a threshold. And then both MME and AIF, they aggregate exposure across the users prior to computing the exposure difference, while the second group of measure, they do not do this. And then the MME and IFD, they are both pairwise measures. So that's why. Okay, moving on to the second experiment. So we measure sensitivity at different ranks, specifically decreasing rank positions. So we use the runs of the NCL model, which has the best relevance scores mostly. And we try to recommend these 5 items from the decreasing rank positions. Then we compute all measures at k equals to 5. So what do we find here? Moving down the rank, we see that the relevance worsens, which kind of makes sense because some of the users have only 1 or 2 relevant items, and then they are all already placed at the first position. So when we shift it down the rank, then relevance worsens. Then exposure-based fairness actually improve because there are more unique items as we move down the rank. But what about the joint measures? So the joint measures actually do not reflect these changes to the same scale. And these are all very small, so 0.2 and lower than that. So maybe we think that, okay, so because relevance goes down, fairness go up, so maybe the joint measures don't change that much because one goes up and one goes down. So it sort of masks the effect. That's why we have the other experiment, which is checking the sensitivity given increasingly fair and relevant recommendation. So now we increase both relevance and fairness by increasing the proportion of relevant items and also by distributing exposure more equally. So to do this, we cannot use the real-life datasets. So we create a synthetic dataset with our artificial recommendation. And we start by recommending the same 10 items that are irrelevant to all users, except for one user where the items are all relevant. And then we replace the item at the back with a less exposed item that is relevant to the user. So here we increase the relevance and we increase the fairness based on exposure. Then we recompute all the measures and we repeat the previous step for rank position 9, 8, 7, and all the way to 1. So that's why with this setup, all the relevance measures, they start from close to 0 and it hits 1 at the end. And the same with the fairness measure, it starts from 0 and ends at 1, except for the purple line, which goes from 1 to 0, and this is because it has lower value as fairer. Okay, so the expected result would be something like this. So the joint measure scores, we expect them to start from the unfairest and reach the fairest. And if not, at least they should become fairer because we increase both fairness and relevance, right? But the actual results is that only IBO and IWO actually start from the unfairest, so 0 or 1, and then all the way to either 1 or 0. And then all the joint measures, they slightly improve, except for IFD. So we can conclude here that most joint measures, they are actually not very sensitive to changes in relevance and fairness scores simultaneously, because the range of these measures, they are less than from 0 to 0.0015, while the single aspect scores, they range from 0 to 1. So this sort of gives the illusion of fair recommendation, even if we start from possibly the unfair scenario. So some explanation of why did IFD become less fair instead of becoming fairer. So IFD measures the pairwise difference in the combined value of exposure and relevance, which is the JUI. And then when we move the relevant items into the top K, the gap between the exposure weight of the relevant items in and outside the top K actually increases. So that's why unfairness also increases. So some key takeaways. There are 4 things that we hope we all can remember here. First one, we should avoid using the similar joint measures. So we found 3 groups, and we should only use 1 measure per group to avoid redundancy, since the measures in one group correlate rather highly with each other. The second one is to be aware of the unintuitive or inconsistent behavior, and also the insensitivity of the joint measures. The third one is to avoid score misinterpretation in measures with naturally small empirical scales. And this is because 2 models differing in scores by, let's say, 0.001, we can interpret them as the models performing similarly. But actually, this very small difference is just due to the nature of the measure's empirical range. Last one, since we have these problems with the joint measures, for now, until we find better measures, then maybe we should measure fairness separately from relevance. So, and this is because of the compressed empirical range, insensitivity, inconsistent alignment to single aspect measures. And that's all from us. Thank you very much for your attention.